Hello everyone and welcome to the first tutorial of week 4. Let's get started. So the first question is, let x be a random variable with CDF fx. Okay, so here we have been given the CDF and most of you would be knowing till by now what is generally what is CDF and what is PDF, what's the difference between CDF and PDF. So yeah, so our CDF is the fx has been defined as 0 for x less than 0, and if x is from 0 to 1 by 2, fx is x square, and if that is from 1 by 2 to 3 by 4, that is x minus 1 upon 4, and between 3 upon 4 to 3 upon 2, that is under root x minus 1 by 2, and if that is greater than 3 by 2, so that will go to 1 because the maximum value of the probability would be 1. Okay, so the first question is, here we have to calculate the probability that x less than 1 upon 4. So how we can write this in the form of fx also. So excuse me. So if this fx less than 1 by 4 can be written in the form of less than equals to form. Okay, we can write this because this is a continuous random variable. So at a specific point, the probability at some specific point can be considered at 0 because this is a case of continuous random variable. Okay, so and we can write this in the form of f, right? And f of 1 upon 4 can be seen from here. So 1 upon 4 will lie between 0 to 1 by 2. So of f of 1 upon 4 would be x square, that is 1 upon 16, 1 upon 4 ka whole square. Okay, now the second question is, we have to calculate the probability of x will lie from 1 upon 2 to 3 by 2. So this can be written in the form of fx also. So with this we can write it as directly as 3 upon 4 minus f of 1 upon 2, right? Either less than equals to 1 upon 2 or less than 3 by 4 or less than equals to, because at if we'll consider in the case of continuous random variable, we can consider both are equal because at some specific point the probability will be 0. Okay, so we can consider this and then we can see the value of f 3 by 4. So the f of 3 by 4 is 1 upon 2 and then f of 1 upon 2 is 1 upon 4. So that is 1 upon 4. So now the third one is f of x greater than equal to 1. This can be written in the form of from a basic probability properties, and if you'll write, this is what this is normally capital F of 1. Okay, and capital F of 1 is how much? Okay, so this you can calculate the calculation. Yeah, this for this last one we can write this in the form of f of 1 upon 4 minus f of minus 1. So f of 1 upon 4 is what? X square. Already we have calculated. So 1 upon 4 ka whole square minus f of minus 1 is 0. So this is also 1 upon 16. Okay. So this was the 4 question that we have solved. So I don't think so there will be any problem in this first question. So solution has also been provided as I have also solved all the questions. These are the solution you can go through if you are not getting. And let's move to the second question of this tutorial. So the second question is, the amount of time in hours that machine works before breaking down is a continuous random variable with PDF given by this. So here we have been given PDF. Okay, so PDF is what? If x is greater than equal to 0, excuse me. So when x is greater than equal to 0, so the effect the PDF is lambda e to the power minus x upon 50. Okay, and when x is less than 0, so that is 0. So lambda can be calculated directly. To calculate anything, we have to calculate first lambda. Okay, so how we'll calculate the lambda here? So from the basic properties of probability, we already know the summation of the, if we have been given PDF, the summation over all the x, the probability of the summation over all the x should be equals to 0, equals to 1. Okay, so what we'll do, we can do the summation of this fx plus minus infinity to infinity, and that should be equals to 1. Okay, so from minus infinity to 0 till 0, the value of PDF is 0 for every point, so we can neglect that, and from 0 to infinity we can consider that, because from 0 to infinity only PDF has been defined for this function. Okay, so what we can do, from 0 to infinity we can write like lambda e to the power minus x upon 50 equals to 1, and after solving this we can get the value of lambda. Okay, so we'll integrate this. Lambda is a constant, so lambda will come e to the power minus x by 50, minus will come here upon 1 upon 50, right? So this can be written as 50 lambda minus e to the power minus x upon 50, and the limit will be from 0 to infinity, right? So we can write the limit 50 lambda, we'll put 0 once, so we'll put infinity, so minus of infinity we'll put minus of infinity, so that will become 0, minus of, we'll put 0, minus of 1, that will equals to 1, right? So if you'll solve it, we will get lambda equals to 1 upon 50. So now the first question is, now we are having the value of lambda as 1 upon 50. So now we are been given what we have to calculate what is the probability that the machine will work between 30 to 70 hours before breaking down. So we have been given the PDF. So we have, what we have to do, we have to integrate it from 30 to 70, okay, of fx, right? So what is that? We have been given that lambda, that is 1 upon 50 e to the power minus x upon 50 dx, right? We have to integrate it from 30 to 70, that you can integrate directly with the word minus of minus x upon 50, that you can put it 30 and 70, so you'll get around e to the power minus 30 upon 50 minus e to the power 70 upon 50. So after using calculator, you will get the value around 0.3. Okay, so this is the solution how to get the value lambda, and then you can directly integrate it from 30 to 70, you'll get 0.3 as the answer. So now the next question is, what is the probability that the machine will work for less than 50 hours? So how what you can do, So you just have to integrate it from 0 to 50. Same method, similar, you have to integrate the PDF. Okay, so now you can write it 0 to 50, 1 upon 50 e to the power minus x upon 50 dx. That you can do e to the power minus x upon 50, 0 upon 50 dx, right? And you'll get and after calculating the integration, sorry, after getting the integration, what you can do, so you'll just what you can do, this won't come here. So after integrating, you can just put the value of x 0 and 50, and you'll get, after integrating you can just put the value, so you'll get minus here. After integrating, you just have to put the limit 0 and 50, and you'll get the value as e to the power 0 minus e to the power minus 1. That will equals to 0.63. So now this is the solution. You can go through that if you are not getting whatever I have said. Now the last part of this question, now you have to calculate the probability that the machine will work for more than 60 hours given that it has worked for more than 40 hours. Okay, so here what you can do, so here it's a simple, you can either do with the conditional method, or you can use the property of memoryless property. Okay, so this is the first method and this is the second method. So if you use the first method, what is that? You have to calculate the probability such that x greater than 60 given that x is greater than 40. That is what has been written here. Probability that the machine will work more than 60 hours given that it has already worked for more than 40 hours. Okay, so that you have to calculate. This you can calculate directly, probability of x greater than 40 and the intersection of x greater than 60 and probability of x greater than 40. So if you'll consider the intersection of both this thing, so what is that? If something is greater than here 40 and greater than 60, so if you have to take the intersection, so x greater than 60 you'll consider, right? So now you have what you have to calculate probability of x greater than 60, sorry, excuse me, x greater than 40 but x greater than 60. You don't have to do anything, you just have to integrate from 40 to integration and here 60 to integration. Just put the value of limit and you'll get the value answer. See here at probability of x greater than 60, probability of greater than 40. So what we have to do, we just have to integrate from 60 to infinity and 40 to infinity, and that's it. Put the limit value, you'll get this. And the second approach is you can directly use the method of memoryless property. And what is that? So if probability of x greater than 60 is there, given x greater than 40, you can just write the difference between 40 and 60, probability of x greater than 20. And this is what you have to do. You just have to integrate from 20 to infinity, put the value of limit, and you'll get 0.67 as your answer. So this was pretty, both the questions were pretty simple. So yeah, let's meet in the next tutorial. So we'll solve there some more questions. Thank you.